Okay,
learning analysis.
let's carry on with continue with our past year paper. May, June 2024, paper 42. Question 7. Okay, we have done question 7, so let's just go very fast with it. Only the last section you didn't complete it. Right? Looks like Faraday's law is quite important now. Every time, looks like every year it come out. So Faraday's law in EMF is directly proportional to the rate of change of magnetic flux linkage. Common show you where they give the mark. This is the first mark, that's the second mark. Figure 7.1 shows a coil of at rest in a uniform magnetic field that is parallel to the axis of the coil. There's a magnetic field, there's a coil. The coil is connected to the center zero voltmeter. You allow it to move either way. If it's center zero. The flux density B of the uniform magnetic field varies with time as shown in figure 7.2. That's how the magnetic field varies with time. Time is in millisecond. B is in millitesla. The coil consists of 340 turns, each of cross-sectional area that calculate the maximum magnetic flux through one turn of the coil. Okay, just memorize the formula and calculate out. Determine the maximum rate of change of magnetic flux linkage. So take the gradient, right? So it depends on how accurate you read. So my one, I get slightly different answer, but it's okay. They allow you half a square mistake in reading. So this is the EMF. This is the EMF. The actual answer is 0.82. Take the maximum electromotive force. Since I calculated 0.72, I write as 0.72. And then on figure 7.3, sketch the variation of EMF V induced across the coil with T for time equals 0 to 6 milliseconds. Okay, so the calculation will tell you really roughly what we are going to do. The slope is 0, so it's a sine graph. There's the gradient of phi t graph. Usually they don't bother about this negative sign. So even if you draw upside down, minus sine graph also can. They will give you the mark. That's the marking scheme. Period, they will look at the period. And then the full graph. Peak at V0 and minus V0. Line showing V equals 0 at 0 here, 2, 4, 6 there. Any comment? Any comment? No,
No.
this is quite common. Reading the sinusoidal graph, variation of V V with T can be described as V equals to A sine PT. A and B are constant. Determine the value of A and B if you need with your answer.
A equals V
So
naught,
V is
so
omega, no?
0.83.
It's 2 pi over T. 2 pi T equals to 10 to the power minus 3, no? 3100 radian per second. A equals to E naught. 0.72. Okay with this one?
Yeah, why would you?
Okay,
Yeah. Yeah.
The next question is usually hydrogen energy level. So it started. Basically, you don't need to know, just know roughly hydrogen energy level. The lowest one is minus 13.6, then minus 3.4. You don't need to know the name of what this one is called, but this is ultraviolet. This one is visible. That's all you need to know. Okay, on figure 8.1 shows part of an emission spectrum of a visible radiation emitted by hydrogen gas in star in a distant galaxy. The galaxy is moving away from the Earth at a speed of 6.2 times 10 to the power 6 meters per second. Explain how the position of the line in the emission spectrum seen by observer on the Earth differ from the position shown in 8.1. Okay,
A
you want to
movement
try?
of stars causes change in observed wavelength.
Movement of star away.
Causing redshift.
Movement of star causes change in observed frequency or wavelength. All three lines shown to the left of the corresponding printed line. Right? That's the marking scheme. Or movement of the star causes redshift. On figure 8.1, draw the three lines in a possible position in the spectrum seen by the observer. Right? Just to the left of the actual line. Okay, that's a marking scheme, how you will get your mark, your 2 mark. Lines of figure 8.1 correspond to electron transition down to energy level minus 3.4. One of the lines represent emitted radiation of wavelength 488 nanometer. Right? When you observe, it's likely to be visible. Visible region. The visible region this level. Right? Not this level. This level is ultraviolet. This level is visible. Calculate the energy of photon of the radiation. Okay, this is from the earlier question.
You see 我能的。
E equals hc over lambda 咯。Right? There's your h, there's your c, there's your lambda. Change to SI unit, calculate out. So there's the energy of the radiation, right? This radiation. Determine the energy electron volt of the energy level from which the electron transition originates, cause the emission of radiation. Right? Basically, we are just using this formula. Higher energy level minus lower energy level, we can change C over lambda. So we have calculated this one as your E. So we want to calculate delta E. Okay, that's your E. Change it to electron volt. Right. That one you have to memorize. 1 electron volt equals 1.6 and 10 to the power minus 19 joule. And then calculate out. So energy level is minus 3.40 plus this one. You want to find E2. So take this one over, becomes plus. Okay. So E1 is given. That's your E1 minus 3. That's your minus 3.40 plus 2.55. Okay, so it's minus 0.85 electron volt. It cannot be higher level, cannot be greater than this value. It must be less than this value. Determine the wavelength in nanometer of the radiation as detected by the observer on the Earth. Right, go to formula sheet. You can remember the formula. Go ahead. This is the formula. That's the formula that we are quoting. Delta lambda, take lambda across. V over C times lambda. V is from the earlier question. C is 3.0 times 10 to the power 8 times 488 is 10.1. So observed one is longer wavelength, we add lah. Any comment?
Oh,
That's what you are doing, okay, good. Value of Hubble constant is this one. Determine the distance of the galaxy from the Earth. That's the equation. Speed of the galaxy, distance of the galaxy from the observer. This is Hubble's constant. So D is V over H naught. V is that one there. H naught. Go to data sheet and read it out. Oh, they are given you. So don't need to look at the data sheet. Well, I think it's not given in data sheet, that's why they're given you. Okay, so we found as 2.7 times 10 to the power 24 meter. Stop me if I'm going too fast. State what is meant by energy of a nucleus. Okay, you want to try?
what energy required to separate the can I say separate the nucleus, or must I state separate the nucleons of the nucleus to
Separate
infinity?
the nucleus into its neutrons, into its nucleons to infinity. Right?
Separate
Basically,
the
nucleus
separate the nucleons.
separate the nucleus into its nucleons to infinity. Energy required to separate all the nucleons in the nucleus are same. Either you break the nucleus into nucleons or nucleons in the nucleus to infinity. Memorize. And table 9.1 shows the masses of two subatomic particles. Right? It's 9.1. Polonium is given. For polonium 212 nucleus, determine the mass defect. Right? Total mass of nucleons minus mass of nucleus. So they are 84 proton. And then 212 minus 84 neutron. Right? 128 neutron, 1.0. And then minus that one. Should be a positive value. If not, you have subtracting wrongly. Then change to kilogram. Right? This is one atomic mass unit. Equals to 1.66 and 10 to the power minus 27 kilogram. Okay.
Okay.
Binding energy is just used E equals to mc squared. That's your mass. The change in mass times the speed of light. Then you get 2.66 and 10 to the power minus 10 joule per nucleon divided by 212. Okay. Any comment or anything not clear? Okay, no question. Let's carry on.
Yep.
Nuclear physics every time will come out either binding energy or radioactivity Sketch the variation with nucleon number A of binding energy per nucleon of A from 1 to 250. So that's all roughly rule. Sorry, there's nothing of this one. It's a smoke curve, that's all. See, harder
Then
to
draw
draw.
like this the exam, will they minus mark?
Okay, the graph like that.
If you draw like the picture you send me, will they minus marks?
Don't follow me there's no harm there.
If you draw like that, will they minus mark?
It depends on the examiner. The examiner will have to decide. That's how it looks like a smooth curve. And then on your line in figure 9.1, draw an X to show the approximate position of 212. Uranium is 238 here. That's the last one there, 238, nearly 250 there. So it's somewhere around there. Somewhere around here. That's what the marking scheme look for. Okay. Action on the line of A that is to the right of the letter A. That's your A to the right of it Mine is too near already And to the left of 2. To the left of 2, correct Okay Probably alright Plutonium-212 is radioactive and undergoes alpha decay. Suggest and explain with reference to figure 9.1 why alpha decay of polonium-212 result in the release of energy? Okay, you want to try without looking at your answer? If cannot, then look at your answer. No?
Mm. Yeah, I think I have to look at my answer.
Okay, it's all right.
Nucleus form as a result of decay as a lower nuclear number. The reaction results in increase of binding energy per nucleon.
Basically, your polonium-212 is here. Then the decay product will be here on here. So the binding energy per nucleon of the product, still the increase in energy. Okay. So nucleus formed as a result of the decay has a lower nucleon number. That's your first mark. Nucleus formed has a greater binding energy per nucleon. That's the second mark. Describe how reflected ultrasound pulses may be used to obtain diagnostic information about internal structure. You want to try?
Time delay gives information about depth of the depth of the boundary.
Time gives information about depth of the boundary. Intensity gives information about nature of the boundary. Define specific acoustic impedance of the medium. Okay.
Product of density of the medium and speed of the ultrasound.
Is a product of density and speed. Speed of ultrasound in the medium and density of the medium. No? They can combine into one sentence. That's how they will look for in the exam. What mark to give. Table 10.1 shows some data for water and for glass. Determine the intensity reflection coefficient for ultrasound that's incident on the water glass boundary. Right, this is what is given in the formula sheet. And remember, go ahead, use it. Right? That is rho times C. And for water is rho is 1,000. D speed is 1420. And for glass, 2,500. And that one, right? Yeah. So use this formula. The subtraction. And the power cancel off. Subtract, add, then divide them, then take the square. Okay, 0.61. Okay, this one like question only lah. Okay, if not, we have completed. Let's go to the next paper. Okay, the next paper we discuss is February, March 2024, paper 42. Got the paper? Found the paper? Yep, found the paper. Explain why gravitational potential nearest to the point mass is negative. Okay, you want to try?
Yeah. The work done is work done by attractive gravitational field to bring a mass from infinity where potential is
Yep,
0.
10.
Yeah.
Can or not?
Teacher, can you hear me? Can you hear me, teacher? Hello?
Yeah,
Oh, you can hear me yet?
can hear you.
Work is done by attractive gravitational field to bring a mass from infinity where potential is 0 to a point closer to another.
Okay, the first one they will give is gravitational potential is 0 at infinity. As the gravitational force between two masses is attractive, so work is done on the mass for 10 more minutes to move it to infinity. Okay, these are alternative answer lah on marking scheme lah. A planet may be assumed to be uniform sphere. It has a gravitational potential phi at a distance r from the center of the planet. The variation with 1 over r or phi is shown in the figure. That's your graph. Phi, I remember, is 10 to the power 8, 1 over r, 10 to the power minus 8. Right? Formula sheet given you there. So you should be able to say what's the equation of the graph. The equation of the graph, we write it if you want to see clearly. That is your y, there's your gradient, there's your x, right? Y equals to mx. Show that the mass of the planet is 8.8, not 8.8 times 10 to the power 25 kilograms, sorry. Right? That's the equation that we have derived. Right? Gradient is G over M. The gradient is right? The easiest way is to take this point on. 2.34 times 10 to the power 8 divided by 4 power minus 8. So we get 5.8, 5.85 times 10 to the power 15. Right? Divided by G. There's a G. Okay,
Uh,
the rotation of planet is 0.72 Earth days. The satellite in orbit around the planet remains above the same point on the surface of the planet. Use the mass in by 1 to determine the radius of the orbit of the satellite. Okay, so this is geostationary orbit. That's the mass that we have calculated. So gravitational force provides centripetal force. Derive the equation. No? Don't try to memorize that. Too many formula to memorize. Derive it. It doesn't take a lot of time. Right? This is the mass of satellite. That's the mass of the planet. R and R cancel off. There's still one R there. M and M cancel off. Or this one, he square that. V square. V square is 4 pi square R square times M and R D square. So this one, so that R and R can cancel off. Still one R there. And this is M and M can cancel off. So this is 4 pi square R squared over D squared. Right? So take R across there. Take 4 pi square down. D squared to the other side and then cube root it. Put in your value. There's a period. Change it to 24 hours. Change to hours. Change it to second. Square that. There's your G. This is your M. Right? You calculated in the previous question. Then 4 pi square. Okay. Any comment? Okay, happy with that. Speed of satellite is given. Mass of satellite is given also. Determine the additional energy required to move the satellite from its orbit to infinity. Right? There's the orbital radius. There's the mass of the planet. Energy required goes to minus kinetic energy of satellite plus potential energy of satellite. Right? Kinetic energy of satellite. Satellite has speed, so we have to put energy there. And this is the potential energy. Gravitation potential energy. Right? You can calculate kinetic energy first, or you can calculate in the equation itself if you want to. And potential energy, calculate out. There's your G. There's your M, mass of planet. There's the mass of satellite. The satellite. R. R is from the previous question. Then calculate out. Okay. There's your R. Just use a different symbol here. And energy required. Minus KE. Okay. Okay. You're happy with it,
Yep.
By referring to both kinetic energy and potential energy, explain what is meant by internal energy of an ideal gas. Okay, you want to try? If you can, without looking. If you cannot, then look at your answer. Just to help you memorize. That's all.
Wait both kinetic energy and potential energy. Right? Internal energy is the sum of kinetic energy and potential energy. No?
Total energy is associated with random motion of molecules. That's your first point. Random must be there lah.
Okay.
Plus total potential energy of molecule, but potential energy is zero lah.
Oh yeah, ideal gas. Yeah. Potential energy
Ideal
is
gas
zero. Yeah.
No intermolecular force. The potential energy is zero.
Yeah, zero potential. So all the kinetic energy. Yeah.
Ideal gas is just all kinetic energy. A fixed mass of ideal gas at temperature 20 degrees Celsius is sealed in a cylinder by a piston, as shown in figure. The initial volume of the gas, thermal energy supplied to the gas, and its volume is in. Volume increases that supply energy to the gas. That's a new volume increases by that amount, and this is a delta V. The piston is freely moving so that the gas is always atmospheric pressure. That means there's no friction, so you don't have to worry about friction. Work done against friction. Atmospheric pressure is given. Calculate the work done by the gas. Right? Just W equals P delta V. Right? P, that's your P. Delta V is given. So it's 5.25 joule. Calculate the final temperature of the gas. Right? Yeah, so the pressure is constant, so use T over V equals constant. T2 is the final temperature. T1 is the initial temperature over initial volume times V2. Put in your value. Initial one is 20 plus 273. Right, this one should be in Kelvin. And V2 is this one plus that. That's a new volume. Cut it up. That's your V1.